up to simple and compound interest. And interest is the cost added to the original amount when you borrow or lend money. And interest is something you're going to be dealing with for the rest of your life. Hopefully for things through like home ownership, through a bank or a credit card company. They charge interest too because they're loaning you money that you'll pay back. And hopefully you never get to deal with loan sharks. They charge really high interest rates. If you're borrowing, you want the interest rate to be low. If you're lending, you want the interest rate to be high. So 4 main terms are involved. I is equal to the interest, and the P is equal to the principal. That's the amount borrowed or lent. R is equal to the rate of interest, and this is always represented as a decimal equivalent of the percent. T is the time, the amount of time that you borrow or lend the money for. And simple interest is calculated for each period only on the principal. Get to what that means in a little bit. The formula used for calculating simple interest is I is equal to principal times rate times time. So if you find the simple interest on a $500 loan at each rate, here's what you're going to do. You're going to take that 7, plug it in there, 0.07, you already have the $500 because that's the principal. 500 times 0.07 times 3 because that's the amount of years, and you get $105. Here, it changes a little bit because it's going to be a longer loan because it's 5 years, so you're going to make more money if you're loaning that money. Or you're going to have to pay back more if you're borrowing that money. So $500 times 0.10, because that's the percentage as a decimal, times 5. So $250. So to pay back that loan, you'd have to pay back $500 plus $250, which is pretty high rate of interest. So try not to do that too much. Now, if you're going to go and graph, this is an example of a graph of if you have $500 in your account, and each year you would draw the interest. Find the total amount of interest you would earn for each year for a 10% annual interest rate for 5 years, and then graph it. So if you look here, for each year, $500 times 10%, so times 0.1 times 1 year would be $50. So that's that. And then for the next year, it's going to be $50 again. So that's $100, then $150, then $200, and $250. And we can graph this. We can figure out how to set up this pretty easily because it's a pretty standard graph: 50, 100, 150, 200, 250, and 1, 2, 3, 4, 5. Then we just plot the points right there. Now, compound interest is more complex, and that's what we're going to spend more time on here. The idea is for compound interest, you pay interest not only on the original amount, but on the stuff that was the interest from the previous years as well. So if you put in this amount here, for here, the $500 into this account, you would have $550 at the end here. But then if you kept it in the account, you would now get the 10% annual interest rate on that $550. So it would then change a little bit. You'd end up getting $55 that next year. And so on. And so it changes, and it gets a little bit more complex. In the formula, there's an added term called the balance, which is just the total amount that is owed or lent. And that's equal to the principal times the, and in parentheses you have 1 plus the rate, still as a percent, and then you have to put that to the power of t, because that determines how many years. This is the function that goes ahead and determines the rate over an amount of years. And if it says find the balance of each compound interest account, all you do is you plug in the information here. I'm doing this in a couple of steps here. Balance is equal to 1,200 times, and in parentheses you got the 1 plus the 0.025. That's what that is as a percent. And over here, same thing. Balance is equal to 3,000 times 1 plus 0.06, and that's in parentheses, to the 10th power. Now, this racks up a lot quicker when you do compound interest. And so I'm going to show you how this works for here. It's 1,200 times 1.025 to the 3rd power. So I'm going to have to resolve this term in a second. I will. And here it's going to be $3,000 times 1.06 to the 10th power. And I'll show you what I mean in a second because I'll put down the calculations. And as you look here, this term here, when I put it to the 3rd power, remember that button there, the Y X button on the calculator. That's what we're going to be using for this. Or excuse me, it's actually, yeah, that's right. So here it is. This is what this term is going to change to if I put in 1.025 to the 3rd power. So it's 1,200 times that, and that's equal to that. Now here, same thing. 1.06 to the 10th power is going to be 1.79. So here you're paying the amount that you would actually go ahead and have or owe would be $5,370. Here would be $1,296. So clearly, compound interest accumulates a lot more rapidly because you're gaining interest on the interest as well.